As we just saw, we need to find new and innovative ways to feed a fast-growing population. And our next guests come from the team here at Microsoft Research that has made that their mission. Joining us is principal researcher Ranveer Chandra, and we have the founder and proprietor of Dancing Crow Farm in Washington State, Sean Stratman. Thanks for being here, both of you. This is fun.
Thank you. Yeah.
Before we dive too deep, we want to start with a new poll question for this session. Put this out to the audience. You guys weigh in on this, and we'll see what your peers think in real time. Here it is. Based on the 2015 USDA data, about 70% of farms have internet connectivity. Which of the following is not in the top 3 of methods by which farmers access the internet? A, cable, B, satellite, C, wireless, or is it D, DSL? What do you think? Cast your vote, and we will reveal those results right after our guests here enlighten us with some other great information, so stay tuned for the results of that. So Ranveer and Sean, before we dive into the technology part of it, tell us a little bit about the current state of agriculture, not just here, but worldwide.
Yeah. So this is well-known studies have shown that by 2050, we need to double the agricultural yield of the world.
Wow.
So one of the key questions is, how do you get there, given that the amount of arable land, the amount of land that you could use for agriculture is not growing, the water levels are receding. So how can you actually achieve that goal in a sustainable way? That's one of the fundamental questions in agriculture that we are out to answer. It's like the way the Green Revolution previously helped actually improve the agricultural yield. We are done with those methods. While we are still investigating those methods, we need another disruption, another breakthrough to get us to double the agricultural yield by 2050.
What about from the farmers' front?
Yeah, well, organic agriculture in particular has experienced tremendous growth in the last 2 decades. Increasingly, consumers are wanting to know how and where their produce is grown, which means good things for small farmers.
Yeah, so this is all good news for you. But of course, then there is coming with the pressure of, can you start growing all of that much, much faster, right?
Exactly.
This is what we're here to tackle. So what role can technology play in these issues? I mean, we saw a little bit of in the video there. Once upon a time, you would think the furthest thing from farming would be computers, but now we're hoping that they can team up to save us.
Yeah, that's an interesting question, because if you look at agriculture is one of the oldest industries, and technologically, it's probably one of the most backward. And not to, so the technical community, the IT community is looking at various ways to solve that problem. Agriculture technology received a lot of funding. So there are various ways in which people are looking to help a farmer. One of the ways in which we're looking at, as I said earlier, is we need a way to double the agricultural yield by 2050. We need a disruption. Right. How do we get there? We are looking at this technique, which was developed around a couple of decades ago, called precision farming. The idea is that instead of the farmer thinking of the entire farm as a homogeneous piece of land, he or she should treat the farm differentially. Different parts of the farm are different. They absorb moisture differently. Some parts of the farm are more fertile than the other. You can plant seeds closer together. Rather than applying irrigation throughout the farm in a uniform manner, apply only where it is needed and how much it is needed. So we think technology can get us there to enabling precision agriculture. The reason, though, even though precision agriculture was developed a couple of decades ago, it hasn't really taken off. And the biggest reason is that it is that getting the data from the farm is still very, very expensive. That is, even though these sensors exist, deploying these sensors are non-trivial. I was at UC Davis a couple of months back, and there was this summit going on where people are presenting their agricultural sensors. And the cost of these sensors are huge. That is, someone was selling 5 sensors for about $8,000 plus a recurring cost. For a farmer who doesn't have that much profit, buying these sensors is non-trivial, especially when you don't know what the end result is going to be, how much benefit you're going to get out of it. So even though technology could help farmers improve yield, the cost of this technology is still prohibitive.
Wow.
Yeah. And historically speaking, every time humanity has experienced any sort of increase in agricultural production, it has been linked to an advancement in technology. If, as Ranveer has said, we are dealing with diminishing resources and increased demand, we must allocate those resources that we are utilizing wisely, and I think FarmBeats is going to help us do that.
Yeah, and just to add to what Sean said, one of the goals of FarmBeats is to allow farmers to enable data-driven farming, enable farmers to have more visibility into their farm. know what their farm looks like 24/7 in a low, inexpensive, affordable manner. So in other words, what we're trying to do is improve the ROI for the farmer, the return of investment. If they're putting in X amount of money, improve yield or help reduce the cost.
It seems like a bit of a no-brainer, right? I would assume that the scariest part of farming is the time investment you put in, and then you got to leave it up to roll the dice and hope Mother Nature does its part, right?
There's a lot of variables involved, and our understanding of those variables is rudimentary at best, and I think having this kind of data come in from our fields will definitely help us in resource allocations.
We do have a lot of folks joining us live right now from all parts. Maybe some of them are sitting on the farm right now, and someone just wrote into us on Twitter. You can use our hashtag and join that conversation, Emerging Tech Summit, if you'd like to pose a question or weigh in on anything you hear today. Got one for you. It says, how do you view, specifically for you, Ranveer, how do you view Wi-Fi evolving in the future? Any major advancements?
Yeah, in fact, that is a good lead on to the next question about when we talk about a system called FarmBeats. So I'll answer the question in response, so while just describing our research.
Sure.
So FarmBeats is an end-to-end IoT platform for agriculture.
Okay.
When I say end-to-end, it means it includes sensors, UAVs, drones. It includes the connectivity piece, Wi-Fi or anything else, along with the backend, the cloud services, the machine learning that can provide useful insights to the farmer. So the goal of FarmBeats is to allow a farmer to be able to view the farm. By viewing, I not only mean viewing in terms of images, but also viewing in terms of the state of the farm. Like how does my soil pH, soil moisture varying over the farm at different periods of time. To be able to get that view everywhere, not every time, not only when they are in the farm, but even when they are away. This includes things like, well, they could change the agricultural practices, they could monitor the farm, even when they are not physically present on the farm.
Sure.
So I have worked with many farmers, including Sean. Sean starts a day at 4 a.m. and ends very late in the evening. And one of the goals of FarmBeats is to make life easier for people like Sean.
Yeah.
So to answer the question, what is FarmBeats? So FarmBeats is an IoT system, as I mentioned. It has two main components, like any IoT system. The first is data acquisition. How do you get the data from the farm to the cloud? And the second is, once you get the data, how do you analyze the data?
Sure.
I'll answer both these questions briefly, and you can read more about it, or if you send we could share a document which describes the system in detail. The first part is data acquisition. The reason this is a hard problem is that farms are usually in the middle of nowhere in a particular sense. So there is very little connectivity. Most of the connectivity scenarios that farmers use are things like satellite or custom cellular solutions, and that's what makes the connectivity expensive. One of the key insights we had was to use a new technology called Wi-Fi that we developed at Microsoft Research, which was to use unused TV spectrum for Wi-Fi-like connectivity. So we are able to send Wi-Fi signals in TV spectrum that is not used. And the key insight was that even though in cities there are a lot of TV towers, in the farms, which are much farther away from the cities, they are far away from the TV towers. So there is a lot of spectrum. So it's not only that you can connect sensors, you can connect cameras, you can send drone videos to the cloud at broadband speeds.
Wow.
So that is one thing about that FarmBeats, and we have deployed the system in Carnation, for example, where we are collecting data from the farms and providing internet connectivity in the middle of farms. And this is what, to answer that question on Twitter, this is one way in which we think Wi-Fi can evolve to help farmers.
Interesting.
So as I was talking about FarmBeats, one problem is data acquisition, where we're able to get data from the sensors, from the UAVs. The interesting thing is sending all the data to the cloud is not feasible, because even though we are able to provide a broadband connection from the farm to the farmer's house, from the farmer's house to the cloud, you usually have a very thin pipe of connectivity. Drone videos, for example, from UAVs, a 15-minute flight would have a video which is about 4 gigabytes in size. Shipping 4 gigabytes of data to the cloud frequently is non-trivial. So instead, what we do is we have a processing engine, which is like a simple PC sitting on the farm, in the farmer's house, which takes the data, processes the data, compresses it, analyzes it, extracts features, and only sends the features to the cloud. So this way, we are able to compress the data and gather all the data and compress them and send it to the cloud. So the farmer gets a complete view without actually shipping all the data to the cloud. And the cost of this is very inexpensive compared to existing solutions, because we are leveraging the TV white spaces. We are leveraging things like existing computers in the farmer's house. And just to complete it, the second part of our of FarmBeats is the data analytics, where we're using vision and machine learning techniques to identify parts of the farm, identify how the farm features vary throughout the entire farm. And on top of that, so what we are able to build is like over an acre of the farm, or even larger, we are able to say how your soil moisture, soil pH, soil temperature, how all these things vary throughout the farm. So this is something that FarmBeats is able to accomplish.
Wow. And as you talked about all the new connectivity issues, let's circle back to our poll question, which we put out to the audience here. We want to pay that off. We asked you guys the question, and we want to find out what you think in terms of connectivity and the farmers and how do they get it. Which of the following is not the top 3 methods by which farmers access the internet? Did you think it's cable? Is it satellite? Maybe it's wireless? Or is it DSL? Which is not in the top 3? 43% said cable. What's your reaction to that?
Yeah, no, that is the right answer. That more cable is, so this goes back to the original motivation of our work, that the connectivity in the farms is weak. You can't really ship all the data to the cloud. So that is why, even though IoT, the Internet of Things, is hot, applying it to farming is probably one of the hardest problems.
Sure.
And that's what we're out to tackle.
Sean, we're in our final minute here. Boil it down for us, farm speak. What does this technology ultimately mean for the farm?
Most immediately, my farm is located in a floodplain that sees serious flooding through the winter months, and a lot of times that flooding will occur when I still have crops in the field. I'm really interested in utilizing this technology and Ranveer's team this next season to monitor the floods that my farm experiences, both keep track of the flow rates and also what crops have been submerged during flooding. That way I can still have documentation of what crops are still marketable and actually have documentation of that. So that's one thing that I'm immediately looking forward to. Also, as Ranveer had mentioned, knowing the relative humidity in the soil and the pH levels and soil temperatures, that's going to be immensely helpful when it comes to spreading lime this next season, or knowing whether or not it's worth adding irrigation to certain crops. If I don't notice crop yield differences due to 20% differences in soil humidity, then it might not be worth it for me to irrigate those particular crops, therefore saving time and money and ultimately making my farm more productive. So I do think this technology will be beneficial for small farmers worldwide.
Great. We are out of time, but I do want to bring in the audience real quick because there are a lot of folks watching. We got a question for you from Twitter real quick. What's the best thing a farmer can do today to improve connectivity tech on their farm?
I think the TV white spaces is actually it's legal now in the US. The FCC's approved it. So you should look up the TV white spaces or Wi-Fi technology, and that is a way in which you can get good connectivity to the farm.
Great. Ranveer, Sean, thank you guys. Appreciate it.